So let's get started. Uh, hey everyone. This is Gaston, and I'm Gilbert. Both of us comes
Hi.
from Mesosphere. Gaston is leading the Mesos team at Mesosphere, and I'm currently leading the containerization team at
Yeah.
Mesosphere. Since we only get one native speaker here, so unfortunately the talk gonna be in English. Apologize for that.
Yeah, sorry for that. My Mandarin is not good enough yet.
Yeah, but we got good translator.
Yeah, I can say anyhow anyway. Okay.
Okay.
So uh, today we will be talking about how to use some tools to do iterative development using Kubernetes. So we will first explain what iterative development is all about, then talk a little bit about CI/CD and immutable infrastructure, some of the challenges that these tools have or these methodologies have, and then we'll present some tools that we will use on the demo to do iterative development on Kubernetes, mostly Rust, Kubernetes, of course, and Scaffold. So there will be like about 10 minutes of slides and then a live demo that I hope will work without network here. So first I want to explain what is iterative development and why it is important. You can see on the left there a waterfall. That's the traditional way of developing applications where you first do, well, you do each phase separately. So you first design your application, then after design is completed and only after it is completed, you develop your application, so people write the code, and only once development is completed, you do the test or QA step. And it has some problems because you always find problems at the last stage that you didn't plan for before, and it doesn't let you do quick iterations or like do quick developments. So a newer approach is iterative development, which is similar to waterfall, in which you go through all the same phases, but you don't do it only once. You do an iteration that is design, development, and testing and deployment, and then you do another iteration, and then another iteration, and on each iteration you add more value to your product. And since you are going to do a lot of iterations, then each iteration has to be quick and cheap to do. And on this talk, we will show you how to do that quickly, how to iterate faster. As I said, if you're going to do iterative development, then you totally need to have some CI/CD tooling. You need to automate how you will do testing because you will do it very often. And you also need to automate how you are going to deploy your applications. And containers are great tools to be able to do that because you can just make your CI/CD tools create a container, and then you can deploy that locally while you're testing and on production afterwards without having to change anything. Another thing that I wanted to talk about is like the evolution from pets to cattle and immutable infrastructure. That's where Kubernetes comes into play. Basically, if you're starting an application and you have very few users, then you have a few servers. And you love your servers, and you give each of your servers a very cute name, like a pet name. If one of those servers has a problem, then you take care of that server. It's like bringing it to the veterinary. You try to fix it, and you give it all your love. But that doesn't scale. If you have hundreds of servers, then you cannot do that. You have to start treating your servers like cattle. You don't give them any cute names anymore. You basically give them boring names like server 1, 2, 3, DB 1, 2, 3, and stuff like that. And then you need some configuration management tools in order to be able to maintain those servers. And that also scales up to a point, but it gets complicated as you have many services. And that's where immutable infrastructure comes into play, where you can define your infrastructure in code, deploy it somewhere, and then have some tooling that will make sure that it can deploy that infrastructure reliably without any problems. Still, even if you have moved to immutable infrastructure, and if you are using CI/CD tooling, and if you're using Kubernetes, you will find out that building, pushing, and deploying your containers isn't trivial. You need to put some effort there at the beginning. And if you have giant binaries or containers, it takes a long time to do the building, pushing, and deploying. Could be minutes to hours, which isn't nice. And it still doesn't solve the problem of safety. Like, you still have to make sure that your applications are safe, both when we were talking about concurrency and also memory safety. So the tools that we will introduce today help you deal with all of these problems. And Gilbert will talk about them a little bit.
So the motivation of this this project is more about like when we do development on our distributed applications, no matter on Kubernetes or any other platform, we need to resolve the problem like you have different teams building toward the same repo, and probably for one single component, you might have like a lot of like contributors which gonna modify the same code base, and you want the test to be quick, efficient, and it could be iterative, quick enough to make sure like, I make some mistake from one team, and it's supposed not to merge to the master branch, and which might potentially impact the other team. So we aim for like improve the velocity of the CI/CD with CI/CD tooling for your own development. So right now it's like a quick introduction about like Rust. So we use Rust with Scaffold on Kubernetes, and it's created by Mozilla, which is like safe, and then it handles like concurrency, and then it is like a practical language. So it is also a low-level language, and performance is also similar to C++. Yeah, this is some base information. We use Rust, and so we do have some challenges with Rust here. So if you look at like some project people talk about in this morning's keynote, people did discuss about like some challenge from Rust, and there are lots of like workaround and solutions. So I will not go into the detail about what challenge it is, because like people could find thousands of ways to work around it. So yeah, so the Kubernetes, people like a lot of part about Kubernetes. Kubernetes, like they have focus on container orchestration. They define a very user-friendly API, and they have a lot of sufficient like operator tooling for your metrics, alerts, servers, and help you to do like easy upgrade. So, and then a lot of like ecosystem around Kubernetes, including machine learning and many other applications like data servers. So we expect to have like Kubernetes to manage containers across different clusters, and we could expect like it's supposed to be like hybrid cloud. Like you can launch the cluster on your on-prem machines, physical machines, and then you could still have your service on public cloud. This enables you to use like immutable infrastructure, and then it becoming a standard to define your distributed application, no matter it's like for CI/CD or any other application. So yeah, and the solution here we're gonna present in the demo, Gastón gonna show you guys. It is based on Mesosphere DCOS. We launched like Kubernetes servers, and then we have the Scaffold running on top of Kubernetes for CI/CD purpose. And a quick introduction, like from DCOS, we did have like one button launch of multi-Kubernetes cluster. So from the UI, you can just like use one button to launch multiple clusters simultaneously, and which is efficient and easy for users to use. This is more meaningful for companies which they expect like they have multiple teams share the same cluster, and they expect multi-tenancy, And it's really up to the user. Like they want, like for example, they want the front end team to use one single Kubernetes cluster, and then they expect their like CI/CD team use another Scaffold on Kubernetes as a separate cluster. So you can all do all those things together with DCOS. Yeah, our focus on this talk is more on how do we run Scaffold, because that's how we resolve the efficiency problem with our CI/CD. Because with Scaffold, we could handle the workflow of like building, push, and deployment of your application. Scaffold did come with the CLI tooling for users to easily to manage the CI/CD. So yeah, and our expectation is like with Scaffold we could iterate the CI/CD application fast enough and shorten the life cycle and make it simultaneously for multiple team development. That's the goal. And here is a quick photo about like the base structure of the Scaffold. I will not go to the architecture detail here. And basically, from the user perspective, because we only care about the user, so we expect Scaffold to build the image, push it to the registry, and then get the deployment done. And all of this should be configured by one single file and easy and quick. So we're gonna unify all the process for user. User no longer necessary to handle all those like operator responsibility. Here is a quick example. Like if you run Scaffold on Kubernetes locally, we don't have push, so we just build it with Docker daemon, build the image, and then Scaffold gonna do the deployment for you. You just need to configure a quick config file. So if you want it to be distributed and then have the Scaffold running on Kubernetes remotely in your cluster, so yeah, you can define any image builder you want. It could be Docker, it could be like Google Container Builder, and you just need whatever registry you want. So it could be Docker Hub, it could be the registry from Alibaba Cloud, or it could be the Harbor project from VMware, which was introduced this morning. And then deployment is also easy on Kubernetes cluster. So for here, we're gonna, for example, MKE on DCOS, which is the multiple Kubernetes cluster on our DCOS, data center operating system. Using Scaffold, we expect like Scaffold could handle all those like bottom layer things for user, and we know the user no longer like have to each of the developers spend days like set up new development environment. So they just focus on the toml file, and that's it. And Scaffold gonna do the rest for you. I think in the next example, Gastón gonna demo. We're gonna show like how to create a Kubernetes manifest and then define a Scaffold, and then you can have your database service running on top of this infrastructure. This is a quick highlight for users. Users just need to save your config and then define your application and trigger the Scaffold on Kubernetes. That's it. And you're supposed to have like your application running. I think we can, because this demo gonna take kind of long and we don't have like VPN access, so we're running it locally. So we're gonna get started right now for the demo. Okay. I can hold the mic for you.
Yeah, that's great. I noticed when I was talking that I will need both hands to type. So as Gilbert said, we're doing this all locally here. So we're going to use Minikube and local Docker registry because I didn't want to trust the network here. All the demo is based on a GitHub repository that is linked in the slides, so you can take a deep look at the code if you want later. What I'm going to do right now is just go through all the steps quickly and show you how you can build your first Rust application very quickly and then use Scaffold on Kubernetes to deploy it very fast, and how you can iterate and do changes and see that reflected. So the first step of that, obviously, is to create your base Rust application. So we will start by creating the skeleton. The first step is to create a cargo toml file where you specify some information about your application. To start with, it will be the name, version, and then the dependencies. We will be using Diesel here for, Diesel is, here for connecting to Postgres to a database. And then we will use Rocket as a web server. Let's do that first step. Once we have the toml file, then we will create a very basic web server that always returns the same stuff, always Rocket web server when you query that. That's enough. It's a very, very little code. Then we will create a Docker file to tell Docker how to build this application. This looks very long because I'm doing some magic here so that it caches the dependencies. So that if you change the code, it will only recompile your code and not download all the dependencies again. So we will just very quickly create the Docker file there. Once we have that, we will also create a Docker ignore file so that we don't include some boring files in our container. And now that we have done all this basic stuff, we have our skeleton, our very basic Rust application. And we're going to run it first just with Docker without Kubernetes, and then we can see how we can use Scaffold and Kubernetes to improve on this. So let's run this application very quickly. Well, first build it and run it. Everything was cached, so that's good. OK. Let's now open the application. Well, actually, I got an error there saying that the container was already running from my preparation, so I will do that again. Just kill it, run it again. It worked this time. And, well, it's still not working for some reason. But we will skip this step. Like this is just running something locally, and I guess I have some misconfiguration in my Docker daemon.
Always risky to do live demo.
But the next step, like this was the basic stuff, just running stuff locally. The fun part is now running things on Kubernetes, and I'm hoping that will work perfectly. The first step is to create your Kubernetes resources. So we will create a service and a deployment that tells Kubernetes how to deploy this Rust application that we're building. We basically include information like the image that we are going to build and deploy and the ports in which it will listen. So we have to create a YAML file there. The next step is to configure Scaffold so that it uses that file to do your deployments and your builds. So the Scaffold configuration is very short. We will tell it what the image is that it should build, then it should use Docker to build it, and that everything should be done locally, and that it should use this YAML file that we just created in the previous step to do the deployments. Having done that, then we can run Scaffold. I will run it with debug information because the first step went wrong, so I want to see errors if something goes wrong again. And we can see that Scaffold is now building something, building everything and deploying that. And actually, if you look here, it is already running on Kubernetes. So we will query this application that we just deployed, just using curl. And yeah, luckily, this deployment worked. So the local one didn't work using Docker, but we just managed to deploy an application on Kubernetes, just creating 2 YAML files. And the next step is to see how easy it is to change your application and have it deployed again. So I'm going to modify this web server and just change the message from Rocket web server to Scaffold updated me. And it's just a matter of changing the file. So I just change the file, and then you will see up here that Scaffold detects that and builds it again. So if we do another curl, we can see that Scaffold updated that. So basically, I just changed one file and Scaffold built it again and redeployed it. So now that we have our basic application ready on Rust, and we have Scaffold configured to build our application, build a container, and deploy it, we will use Rust and some Rust frameworks to make this application talk to a database, a Postgres database, and then write some code so that we have a REST API to modify. This will be a pretty boring application, just a service that lets you maintain a list of employees and add and remove them. But you can use this as an example and then do something more fancy in real life. So the first step is to deploy PostgreSQL. I'm going to do that in a very huggy way, just running it as a single container without any persistent storage or anything like that. It's just something for the demo. I don't recommend doing that in production. So in order to do that, we will basically add a Postgres service and a deployment here. And we're just going to use the Postgres image and a hard-coded username and password. Again, you shouldn't do this in production. This is not HA at all, not highly available at all. But it works fine for demos. OK, so now it will take Scaffold a little bit to deploy that. Well, let's see where it's done. So in order to be able to create tables and stuff like that, I'm going to use kubectl to set up a port forward from localhost to the Postgres instance. In this case, it's running on my local machine on a VM, but it could be on a remote Kubernetes cluster. So you will need an easy way of creating tables and basically running your diesel migrations. So this command will take care of that. And we will leave it running on a separate console here. And apparently, it didn't work. Let's see why. Before doing this, we noticed that when there were some networking problems, that didn't work. OK. I will increase the font size as well. OK, so it's the same error that we have before. It's trying to fetch the image from the network, the Postgres image from the network. Let's see whether I'm lucky now and then Wi-Fi works better. We had said this so that it wouldn't do that, but apparently that wasn't enough.
Yeah, probably you might need the VPN to pull the image. Yeah, so while Gastón is trying out this with pulling the image, so basically like we did find the scaffold running on Kubernetes boring, but basically in infrastructure they are all becoming boring. Only if like it could resolve the problem from user, we find it valuable, because like when we are working on container solutions like CSI, container storage interface, CNI, and Kubernetes, as well as like Jen mentioned this morning. So this infrastructure solution, it might be boring, but it really make operators' life easier. And hopefully we expect like this could change like unify the process how operator work with cluster.
OK, so I got lucky and network just worked when I enabled Wi-Fi again, so it could get the Postgres image. So now we can see that we can connect to the Postgres database, and now we have to just create the right tables and that stuff so that our application can use that. I will assume that you have already installed Diesel. I have already installed that, but it provides a nice CLI that you can use to create your tables and then to run migrations, rerun them, and stuff like that. The first thing that you have to do is create an environment file telling Diesel how to connect to your database. In this case, we have a service. Well, we have the port forward that I used before, and then the username is Diesel and change me the password. Again, don't do this in production. Having that, we can tell Diesel to run the initial setup, and then create the basic templates that you can use to iterate on your application. So this created two files. One is the up SQL script, and the other one is the down. The up one is trying to create all your tables, and the down one will destroy everything. We will create a very basic table, just a single one for employees with just a first name, last name, age, and title. So we will add that to the up migration. And then the down migration will be very boring. It will just destroy all the tables. Let's use Diesel to run that and create a table. And OK, now we have Postgres running on Kubernetes, and we use Diesel to create the tables. The next step is to make our application connect to this database that we created. In order to do so, we will create a new file, a Rust file, and that has a method that will give you a Postgres connection. Here you're seeing that it uses it gets the database URL from the environment. I will then update the Kubernetes resources so that this is populated by a secret. The next step is to create the matching model for this table that we created. It is a very simple class, well struct, with the same fields as the table. And then this has some magic that will do the mapping between the table and this struct. In order to do so, we have to call this tool that will generate the code. And basically now we have a Rust application that has all the models and connection logic to talk to your Postgres database. We have a Rocket web server already set up, and we have a database running, so we have to bring everything together. The first step to do this is to just insert a default user, or sorry, employee. Will be very boring, will be called some person that is a software engineer and 25 years old, and then we will list that. So we do that manually. And yeah, we see that something was created. The next step is to add that secret to Kubernetes, so it's possible for our application to find the URL and be able to connect to the database. This bit here does that. These characters that you see here is basically this text here, which has the password and username and the host name encoded using base 64. Again, you can see I just added, I appended that to the existing file with the resources, and then Scaffold automatically takes care of creating the secret for me. So it will watch this directory and apply all the changes on the cluster. The next step is to update the current deployment for the application and make it use this secret that I just created. OK, it was just doing that. And now that we have that, and everything was deployed successfully, we can then update the application and bring everything finally together. So we will update our application so that it fetches the first employee and returns it when you do a query. Just do it here. We wait for it to be deployed. It was deployed. We can see it here. So when we get the index page, we should see the information of that user. So we have some person that we created. So yeah, we basically now have our application connected to the database. And the final step is to implement the REST methods so that you can add, list, remove, and update employees from your database. In order to do so, we have to change the models that we created in the previous step and tell Rust to derive some more traits, so it's possible to query, insert, debug. Well, yeah, so it implements more interfaces, and we can do more stuff in our code with this model. And then we need to do some boring classes so that we can handle errors and input from users. So basically, this uses here Rocket Forms so that we can get employees as JSON. Again, just a handful of lines of code. Rust makes it really easy. And finally, here's where all the magic is. I wish I could go into details, but I only have 5 more minutes left. So if you want to see this, you can take a look at the repo that I'm using here. But this is all the implementation for the HTTP get, put, post, and delete methods. It's less than 200 lines of code. So it's really short and concise. And I'm just going to replace the previous file with this one and change our main file so that it uses these methods that I just implemented. And that's basically the final step. Now, Scaffold will redeploy that. It actually did very fast. Here we see now it is exposing all these methods, and we will try that. So first, let's try getting the first employee. So you see here employees 1, and it should return that information from that employee that we had created in the previous steps. And again, it's not working. In the past, we saw this method sometimes takes long after network changes. Yeah. So that's what was probably taking long. Let's do. OK, so doing that manually worked. You can see all the employees. And if you care about only just one, you can just specify the extra one there. We can also add new ones. Let's see where this works now. OK, yeah, this Minikube is being slow on my machine. But if we put the URL manually, then everything works fine. So basically, we're going to add a new employee here. Yeah, OK. Well, yeah, basically, we implemented all the methods. And Gilbert just told me I have only 3 more minutes. So yeah, do you have any questions? Can go to. OK, so sorry, before questions, there's there a link to the full demo using DCOS. So if you want to see, read all the code in depth and see all the Scaffold examples and everything like that, you can just go there. You can also read more about Mesosphere Kubernetes engine on this link. And here are some future work, some improvements that you could do. Like you could run Postgres on HA mode and do 0 downtime deployments using probes and stuff like that. But we skip that in this demo.
So if I remember correctly, you did record some video for the webinar, the CNCF webinar for Scaffold on Kubernetes, right?
Oh, yeah, yeah. If you Google my name and Rust Scaffold Kubernetes, you can see a CNCF webinar. And that one is slower because we had a full hour and goes in depth. And that uses CDCOS as well.
Okay, so as the last for this talk, I want to summarize so you guys might be curious oh, you guys this Mesos people, why are you attending Kubernetes Con? Why are you presenting the work supporting Kubernetes? And how's the competition between Mesos and Kubernetes? So yeah, I got a lot of those questions for the time being. So I just maybe this is a good chance to make clarification here. We don't have competition relationship, and then we do in our product DCS we do have support Kubernetes on our product, and we have Kubernetes running on top of Mesos easily, and it works well in production. So these two components, they focus on different layers, and also it's totally up to user. You want more on resource allocation, resource management, or you want more on container orchestration. Do you want single scheduling strategy, or you want the fairness resource arrangement for your task? So it's totally up to the user. And on our platform, our users and customers, they could either run Mesos task or Kubernetes job. It's totally up to the user, and most of them, they just run both on their clusters. It's totally up to like what the application it is, what's the purpose, and yeah.
Yeah, just one quick slide. We wanted to thank Shane, who did the original demo that I linked to, and then York, who also helped with the slides for the webinar. And yeah, any questions? I think we have like a minute left.
Okay, yeah. So thanks for joining this talk. And if you remember any question, feel free to visit our webinar or our Slack channel to ask, to discuss with us. Thank you, guys.
We also have a booth, so you can find us there. If you have any questions, we will be around and at the Mesosphere booth. Thank you.